Okay, so this is 9.4 day 2 notes. Make sure you have your unit circle out and then that trig identities worksheet, or not worksheet, sheet of all of those identities out too. You're going to be using them today. Example 3, solving trig equations with trig identities. Okay. Use the trig identities to solve each equation from 0 to 2 pi. So since it gives me 0 to 2 pi, I know I'm working with radians and not degrees. Alright, first thing, when we look at here, I have 2 cosine squared equaling sine plus 1. With this, we usually try to get it so we have all sine or we have all cosine. Okay, working with 2 different trig functions is not really possible, so that's why we're going to try making it into all of the same. Okay, so I'm going to look at my identities. I will kind of help lead this one. I know that I can change cosine squared into something with sine squared. Okay, so if you remember back when we have this, I have cosine squared theta plus sine squared theta equaling 1, and I want to get it so I am having the sine squared by its, or the cosine squared by itself. I'm going to subtract the sine squared from both sides, and then that would give me cosine squared theta is going to equal 1 minus sine squared theta. Okay? So what that means is this cosine squared theta, I'm going to substitute it in for 1 minus sine squared theta. So I'm going to have 2, then 1 minus sine squared theta, and then this would equal sine theta plus 1. Okay? Then we're just going to start solving. So I'm going to actually distribute this 2. I would have 2 minus 2 sine squared theta equaling sine theta plus 1. Okay. If you want to switch that sine out for x to make it a little bit easier, you can do that. So you can say sine equals x. Okay, so then I would have 2 minus 2x squared equaling x plus 1. Okay. Now we want to solve for what x would equal. I'm going to get everything to one side and equal it to 0. So I'm going to add 2x squared, and I'm going to subtract 2. Okay, so this would be 0 equaling 2x squared plus x, and then that'd be minus 1. Okay, so I am multiplying 2 times negative 1 is negative 2. And I'm adding to 1. So then this would give me 2 and negative 1. Since I have a number in front of my x, I do have to factor by grouping. So I'm going to have 2x squared plus 2x minus 1x, and then minus 1. We group the first 2, and then we group the second 2. Okay, now we have to look for a greatest common factor. So in here, I can take out a 2x, and then I would have x plus 1. Here, I can take out a negative 1, and then I would have x plus 1. Okay, so then I write what is in my parentheses, so I'm going to have x plus 1, and then I write what is left over. So I'm going to have the 2x minus 1. Okay. So then from here, I am going to substitute that sine back in. So I'm going to have sine, I'm just going to come up here. I'm going to have sine plus 1, and then 2 sine minus 1 equaling 0. Okay, set both equal to 0, so sine theta plus 1 equals 0. And 2 sine theta minus 1 equals 0. Subtract the 1, so sine is going to equal negative 1. I'm going to add the 1, so I have 2 sine theta equaling 1, divide by 2. So sine theta would equal 1/2. Okay, looking at my unit circle. Let's look first where sine equals -1. So sine is that second number. So I would have sine equaling -1 here. So I know my theta is going to be 3 pi over 2. So theta equals 3 pi over 2. And then on here, sine equaling 1/2. I have it equaling 1/2 at pi over 6. So I know theta is going to equal pi over 6. And then sine equaling 1/2 I also have at 5 pi over 6. And that would be that answer then. Oops. Okay, so you ended up having 3 total answers. All right, I want you guys to try out B and see if you can come with that. My hint for you is you are going to use a double angle for this one. Okay, so that is going to be a double angle. Okay, so first thing, I'm just going to do it on here. I have sine 2 theta equaling negative cosine theta. Okay, so like I said, we are going to use our double angle for this. Let me grab that. So I know my sine 2 theta is going to equal 2 sine theta times cosine theta. So I'm going to write that. 2 sine theta cosine theta equaling negative cosine theta. Okay, you never want a double angle, so you're always going to, anytime you see that, turn it into something else. Okay, so for this one, there's really not much I can do right now. So what I'm going to do is I'm going to actually set this equal to 0. So I'm going to add the cosine theta. Okay, if you guys got this, I'm going to be super impressed. Okay, so I have then 2 sine theta times cosine theta plus cosine theta. Okay, so the reason that we can't add these together, it would be saying like 2, and then we'll say yx, so like sine is y, cosine is x, and then we plus x. Okay, you can't combine these because they aren't like terms. So same idea, you can't combine these 2 cosines because we have this multiplying by sine here. Okay, and this just equals 0, sorry. All right, with this then, what you are going to look for is a greatest common factor. So can I take something out of both of these? Okay, well I do have a cosine in both, so I'm going to factor out a cosine theta. So I'm going to divide each term then by cosine. Okay, so that's going to cancel. That's going to cancel. So I would have 2 sine theta. And then just be careful. Cosine divided by cosine is 1. And then that would equal 0. Okay. Now I have 2 factors equaling 0. So I can set those both equal to 0. So cosine theta equaling 0. And 2 sine theta plus 1 equaling 0. Don't have to simplify any of that. So here I would subtract 1 and divide by 2. So sine theta is going to equal negative 1/2. Okay, now we're going to look at the unit circle and look to see where cosine equals 0. Okay, well I have cosine being 0 here, so it's going to be pi over 2. So theta is going to be pi over 2. I also have cosine being 0 at 3 pi over 2 though, so just be careful with that one. Okay, so there's 2 answers. Now I just need to look for where sine theta equals negative 1/2. So those are going to be positive. My sine's positive here. Okay, so sine is -1/2 at 7 pi over 6. So theta is going to be 7 pi over 6. And then -1/2, I have it right here, which is 11 pi over 6. So 11 pi over 6 are my other two answers then. Okay, like I said, if you got that, I'd be super impressed. This is new stuff, so it is going to be difficult at first. But I know the people that joined me on the Zoom, I do think it got easier for you guys once you practice. So it's gonna be the same idea. Once you get that practice in, it'll get easier. Okay? All right, let's look at some more examples though. So C and D now, we are working from 0 to 360. So what that means is we are now gonna be working in degrees as opposed to radians. Okay, so same idea. I do have, if you guys want to try these by yourself first to get that extra practice, you can do that. Otherwise, you can watch the first one and then try out D. Okay, so I have a double angle. So we are going to switch that to make it so we don't have a double angle. Problem with this though is I have 3 different options that I could choose for this. Okay, so we're just gonna kind of go through and maybe do process of elimination to see which one would work best. If I switch it to here, I would have cosine squared minus sine squared, and then I would have another cosine. From there, I have 2 different functions going that are squared, so that's kind of hard. So I can't do any like factoring or anything. I wouldn't be able to take out a greatest common factor because this doesn't have a cosine in it. So that one probably is not the best, okay? If I were to go down to this one, I would have 2 cosine squared minus 1. With this one, I would then have a cosine squared and a cosine, which we've been working with. We're able to factor that then. So I'm actually gonna choose this one. It also gives it so I only have cosine in my problem, so that usually is a little bit helpful too. Okay, so I'm going to say that this is 2 cosine squared theta minus 1 plus 3 cosine theta plus 2 equaling 0. Okay, if you like making it x instead, that is totally fine. So I'm going to have x equaling cosine theta. So I would then have 2 cosine, 2x squared. And we're going to combine like terms. So my next term then would be plus 3x. And then -1 plus 2 is 1, equaling 0. Okay, so now you have to factor this. This would then give me 2, and then I'm adding to 3. So this would be 2 and 1. So I'd have 2x squared plus 2x plus 1x plus 1. Okay, so that's the 1x and then that's the plus 1. First 2, second 2. Greatest common factor is 2x. It'll be x plus 1. Don't need to really take anything out of that because that's already x plus 1. And then I'd have 2x plus 1 and then x plus 1. Hopefully this is a skill that comes back pretty quick for you guys. Now from here, I am going to substitute that cosine back in. So I have 2 cosine theta plus 1, and then cosine theta plus 1 equaling 0. Set them both equal to 0. So I'd have 2 cosine theta plus 1 equals 0, and then cosine theta plus 1 equals 0. Okay, so this one, cosine theta is going to equal -1/2. And then cosine theta is going to equal -1. Okay, looking at my unit circle, cosine equaling -1/2, which would be right here. Only thing with this though is we are working with degrees, so it's going to be 120 degrees. So theta equals 120 degrees. Let's see if we have another cosine being -1/2. I have a -1/2 here for cosine, so then it would be my degrees, which is 240 degrees. Okay, so there's 2. And then cosine equaling -1, which is right here, which is at 180. So then it would be 180 degrees. So those are my answers for that one. Okay. You can try out D and then see what you get with that. Okay, so first thing that I noticed, I have a squared, but this is a cosine. So I'm gonna try to switch this in order to get it to be a cosine squared. Okay, I'm just going to write it here. I know sine squared plus cosine squared equals 1. I want to get this sine squared by itself. So I'm going to subtract cosine squared to both sides. That means I have sine squared equaling 1 minus cosine squared. Okay, so I'm going to substitute the sine squared for 1 minus cosine squared. That way I would have 4 and then times 1 minus cosine squared plus 4 cosine. And I'm actually just going to subtract this 5 over right now, just kind of combining some stuff together. Okay. If you want to put it to x right now, that is fine. X is going to equal cosine. So I would then have 4, 1 minus x squared plus 4 times x minus 5 equaling 0. Distribute this out, so it'd be 4 minus 4x squared plus 4x minus 5 equals 0. Okay, now write this in standard form. So this would be negative 4x squared plus 4x, and then 4 minus 5 is a negative 1 equaling 0. In order to factor this though, we can't have a negative, so we're just going to take out a negative, and I would have 4x squared minus 4x plus 1 equaling 0. Okay, so I'm multiplying. 4 times 1 is a positive 4, and then I have a negative 4. That would be negative 2 and negative 2. So then I would have 4x squared minus 2x minus 2x plus 1. My first 2, second 2. I can take out a 2x. I'd have x minus 1. I can take out, oh sorry, this should be a 2x. I can take out a negative 1 here, and then I would have 2x minus 1. So then I would have 2x minus 1, 2x minus 1 equaling 0. All right, switch those back to cosine. So I'm going to have 2 cosine theta minus 1, and then 2 cosine theta minus 1 equaling 0. Okay, so since they both are the exact same thing, I only have to solve for 1. So I'm just going to have 2 cosine theta minus 1 equaling 0. I'd add the 1 and then divide by 2. So cosine theta would be 1/2. Looking on our unit circle, I have cosine being a positive 1/2. So I'm going to be right here. We are looking at degrees because it said 0 to 360. So that's going to be 60 degrees. So theta equals 60 degrees. And then I also have cosine being 1/2 at 5 pi over 3 or 300 degrees. So this would be then 300. Okay. Make sure you finish up your homework. Let me know if you have any questions. Like I said, I know this is difficult stuff, but so far you guys are doing pretty good, and I'm pretty impressed with what you've done. Okay? Have a good one.